Okay, welcome back. So today we are going to talk about particle motion again. Now we've looked at it before, but we just kind of want to revisit it and see like what integration can bring to particle motion for us. What knowledge can integration give us? So here I've written down some vocabulary, and I just want you to pause. Maybe I can see if I can get all of this in the shot so you can see everything at once. Can I do it? Maybe no. So okay, I'll scroll here. So here I'll just do the first ones, and then we've got position, which is usually s of t or x of t, average velocity, which is s of b minus s of a over b minus a, as opposed to instantaneous velocity, which is the derivative of our position, or just v of t, that's velocity. Speed is the absolute value of velocity, and if you want, you can pause here so you can kind of review some of these because I'm going through them kind of fast. But acceleration is the derivative of velocity, or the second derivative of the position. Displacement. Now here's when we're bringing in our integration. Displacement is going to be that distance, the difference in distance from start to stop, so a to b of s of b minus s of a. But distance is going to be how far we actually traveled. And that's going to be the integral of the absolute value of v of t. Think of this now, the displacement is how far you've ended up, but the distance is how far you've traveled. So if you're walking back and forth, back and forth, back and forth, or let's say you're just walking in a circle, you haven't really gone anywhere. And I can kind of demonstrate this better in class, but that's the difference between those. Then we've got free fall motion when you're just dropping. That's the position is negative 1/2 g is our gravity, t squared minus initial velocity times t plus initial position. And our gravitational constants are 9.2 meters per second squared, or 32 feet per second squared. So again, pause this if you want to take some moments to review this. But we have two examples we're going to go through, and then in class we'll be working on some problems together. So an object moving along the x-axis so that its velocity at any time t equals 0, or t is greater than or equal to 0, is given by v of t equals 3t squared minus 10t plus 3, and the position of the particle at time t equals 1 is x equals 3. We want to find a position function for the particle. Well, we've been given the velocity, and so we need to actually find the position. Well, s of t is just going to be equal to the integral of 3t squared minus 10t plus 3 dt. And if we take this integral, we're going to get t cubed minus 5t squared plus 3t plus c. Okay, that's our s of t. But that doesn't really give us our final answer there, right? What we actually also need to find is the full thing. We need to find what c is. So we know that s of 1, I don't know why I wrote t again, s of 1 is equal to 1 minus 5 plus 3 plus c, which equals 3. Okay? So, and I just kind of substituted quickly there, but if we calculate this, we're going to get that c is equal to 4. So our position function is that s of t is equal to t cubed minus 5t squared plus 3t plus 4. All right? And you did a problem like this during our check day, and I think you kind of understand it, but we'll keep going anyway. So we want to find the displacement of the particle from time t equals 0 to t equals 6. Well, our displacement, as we learned earlier, is the integral from 0 to 6 of our function here, of v of t. Well, v of t is 3t squared minus 10t plus 3 dt. And you could put this in your calculator, but I'm not going to. I'm going to actually do it. So this is going to be t cubed minus 5t squared plus 3t evaluated from 0 to 6. So I'm going to get 6 cubed. Okay, so 6 cubed is 216 minus 5 times 36 is 180, excuse me, plus 18, and all the rest of that 0. So this equals 54. Okay? Now we want to find the distance that the particle actually traveled, okay? Well, the distance that the particle actually traveled is going to be, you know, the entire distance. Here we've got a t cubed, so that means that our particle is kind of going up and down, right? So I'm going to rewrite this as the integral from 0 to 6 of the absolute value of v of t dt. Okay, 1 second here. Okay, and so I'm going to pull in my calculator here. What I actually need to do is integrate the entire thing, but I need to know where my points of inflection are. So I've graphed this, and I mean, I could do this, I guess why am I not doing it? But anyway, I could find the zeros. In order to do this by hand, you would find the zeros, but I'm just going to do this on my calculator. So I've graphed it, I go to my graph, and I'm going to trace and find my zeros. And I actually already know, so I'm just telling them to you. They're at 1/3, and they're at 3. So I need to find, if I'm finding the distance from 0 to 6, I need to find that distance from 1/3 to 0, or from 0 to 1/3, and then from 1/3 to 3, and then from 3 to 6, right? So I'm going to end up having, and I can show you what this looks like. If I integrate this, I go from 0 to, oops, I typed too soon there. My lower limit's 0, my upper limit's 6. So you can see here, and it's kind of hard because this is a pretty small graph, but I'm going to have a little bit here, a little bit here, a little bit here. Now, if I integrate that whole thing, I get 54. That's my displacement. I already found that. But I need to find this integral from here to here, here to here, here to here, so that I can add all of those up and actually get my displacement. So this is going to be equal to the integral from 0 to 1/3 of v of t dt, plus the integral from 1/3 to 3 of v of t dt, plus the integral from 3 to 6 of v of t dt. All right? And these are all absolute values. So this is going to equal, I'm going to pause here and just actually put in the answers because you actually know how to calculate this. Okay, so I calculated these, I add them up, I get 1970 over 27, which is about, oops, I don't want it as a fraction anymore. I want it as a decimal, 72.963. Remember, you should be using 3 decimal places in calculus. So that's our distance that we traveled, even though we were only displaced 54, okay? Let's do another example here. A potato is launched straight up from the ground level and reaches its greatest height at t equals 6 seconds. We want to find the initial velocity of the potato and the value of its maximum height above ground level. Well, the first thing that we want to do is identify, well, at s of 0, our initial position, we're at 0, right? We're at the ground level, so we're at the very bottom. And our velocity at time t equals 6 is equal to 0, because that's our greatest height, right? Well, we know that our v of t is going to be equal to the integral of negative 32 dt, because that's what we're working against gravity, right? So v of t is going to be equal to negative 32t plus v sub naught, our initial velocity. That's our v of t. And v of 6, we know, is equal to 0. So v of 6 is negative 32 times 6 plus v sub naught equals 0. So we're trying to solve for v sub naught here. So negative 32 times 6, whoops, I wrote times 3, is negative 192 plus v sub naught equals 0. So our initial velocity is 192 feet per second. Don't forget that you always have to label. So we found our initial velocity, and we want to find its maximum height above ground level, okay? Well, our maximum height above ground level, so we actually know that v sub t now is equal to negative 32t plus 192. Our maximum height, s of t, is going to be the integral of negative 32t plus 192 dt. Okay? And so if we integrate that, we get negative 16t squared plus 192t plus c. And we know that s of 0 S of 0 is equal to 0. This is our S of t, right? S of 0 is equal to 0. So, I mean, I guess I could do this, but C is going to be equal to 0. So, S of t is just equal to, our final S of t, is equal to negative 16t squared plus 192t. What's its maximum height? Well, its maximum height is when its maximum velocity is at 6 seconds. So S of 6 is equal to negative 16 times 6 squared plus 192. I'm running out of room here. 192 times 6. So we can calculate that. So we're going to get a negative 576 plus 1152. So our maximum height is 576 feet. All right, good. Hopefully all of that makes sense. We'll do some problems together in class if need be, working in our groups. Hopefully you are kind of seeing how integration and differentiation and particle motion are all connected. Like and subscribe. Questions in the comment section, and I'll see you in class. Goodbye.